Continuing on then, I'm going to draw this molecule and show its polarity. I have two hydrogens. They're in group 1, so they have 1 electron. I have 1 oxygen. He's in group 6, so he has 6 electrons. Add those together, I get 8 electrons. Alright, so I'm going to draw it. I want to make it symmetrical. I'm just going to distribute my 8 electrons. Okay, now oxygen has 8, hydrogen has 2, everybody's happy. Now I want to show polarity. Well, hydrogen's at 2.1, and oxygen's electronegativity is 3.5. So oxygen is stronger. So in this shared bond, oxygen is going to pull it closer to him. Since it's more in that direction, this side is going to be a little bit negative, and this side is a little bit positive. And same thing over here. This side's a little negative, and this side's a little positive. So we have polar bonds within the molecule. And my next question is my molecule polar as a whole? I look for symmetry. If it's asymmetrical, it's polar. Okay? Well, I have one side here that's different than this side, and different than this side. So two sides are the same, two sides are different. So all four sides are not the same, so it's asymmetrical. So my molecule as a whole is a polar molecule. Alright, draw this guy, show the polarity of each bond, and then tell if the entire molecule is polar or not. Alright, now go ahead and draw this molecule, show the polarity of each bond, and tell if the whole molecule is polar or not. We'll pause the video and start when everyone's done. Alright, bond strength. This is something I had you memorize before. Remember, we have bonds between atoms, and those bonds would be ionic or covalent. Those are strong bonds. Those are the strongest. And then we have bonds between molecules, intermolecular bonds. And typically we say those are weaker. And we have hydrogen bonds. We have dipole interactions. And we have dispersion forces. So we're going from strongest to weakest. Now remember, the hydrogen bond is something that involves hydrogen. So water. Water is attracted to other waters by hydrogen bonding. So if I have a water with a negative side and a positive side, okay, and another water comes floating by with a slightly negative side and a slightly positive side. Well, everybody knows opposites attract. Minuses are attracted to pluses, so that's going to be a hydrogen bond right there. So obviously for hydrogen bonding we need hydrogen. Okay, a dipole interaction is the exact same thing, but it does not involve hydrogen. So two polar molecules attracted to each other would be a dipole interaction. And then remember, dispersion forces. Everybody has dispersion forces. That's just the attraction of the electrons for the opposite atom. The more electrons, the more dispersion forces. Dispersion forces are what allows something like hydrogen or helium to be liquefied. There's a small attraction there based on the electrons. All right? Alright, what I want you to do here is list out the bonds that exist between the atoms. Is it covalent or ionic? And then list out the bonds that would exist between the molecules. So let me do the first one for you. So CH4, well, I know those are two nonmetals. Two nonmetals are going to be covalently bonded. So between the atoms, a carbon is attracted to a hydrogen by a covalent bond. So that answers my first question. My second question says, how is one CH4 attracted to another CH4? Okay, it's going to have dispersions. Doesn't have dispersion forces. Always has dispersion forces. Well, there's hydrogen there, so I'm going to have hydrogen bonding. Go ahead and do that same thing with the next three questions. All right, lastly, we're going to name some molecular compounds. Remember, with naming molecular compounds, we got to use prefixes. We never ever use these prefixes for ionic compounds, just covalents. All right, so all we have to do is use the prefixes. Let me show you the first one here. I have N2. I have two N's. 2, my prefix is di. So di nitrogen. And then 4 hydrogens. My prefix for 4 is tetra. And then hydrogen, I switch to ide. I always change the last one to ide. Alright, go ahead and pause the video, finish the last 4, and then restart the video. One last thing, I just said that CH4 has hydrogen bonding. It doesn't actually have hydrogen bonding because it's a nonpolar molecule. So we don't need to worry about the hows and the whys of that. But just so you know.